Tonight, we drift inward toward the deepest place our planet allows us to know. Beneath our feet lies a boundary no human has ever crossed, a place where tools fall silent and understanding must come without sight. The Earth stretches nearly 4,000 miles from surface to center, and yet the deepest hole ever drilled reaches only a tiny fraction of that distance, less than 1%. Everything beyond that thin outer shell remains beyond direct reach. No cameras, no hands, no journey downward. The ground we walk on does not stay solid for long. As depth increases, heat rises faster than in almost any other place humans try to explore. Pressure builds so quickly that familiar materials no longer behave as we expect. Rock stops breaking. It begins to move, slowly flowing, closing the very paths drilling depends on. So scientists listen. They study the vibrations of earthquakes as they pass through the planet, bending, slowing, and changing as they move through hidden layers. From these distant signals, careful models emerge, quiet reconstructions of a place no tool can touch, a planet understood without being seen. But how do we know the Earth's core exists if we have never reached it? What stops us long before the center is reached? How does pressure turn solid ground into motion? And is this boundary beneath us a limit of technology or a limit of nature itself? Tonight, we drift to the edge of how far inward humans have ever been able to go. But before we begin, if you find peace in these gentle journeys where science drifts like a lullaby, I'd be so grateful if you gave this video a soft like or tapped subscribe so that more curious dreamers can join us here. And if you'd like, let me know in the comments where you're listening from tonight and what time it is there. It's always such a joy to see how far this little sleepy corner of science can travel across the world. So now take a deep breath, let your shoulders loosen. Now let's begin. We live on a boundary so thin it almost disappears when the planet is viewed as a whole. Everything familiar unfolds there. Light, air, water, movement, memory, all balanced on a narrow outer film that separates the known from an interior too vast to touch. The ground feels permanent because it carries our weight, yet permanence here is an illusion created by scale. Compared to the body beneath it, the surface is barely present. The crust, the only solid layer humanity has ever occupied, varies in thickness, but never enough to change its insignificance. Beneath oceans, it is thinner still, stretched and fragile, while continents rest on slightly deeper foundations that feel immense only from a human perspective. Measured against the full radius of the planet, these differences vanish. The entire stage of human history exists on a shell so slight that it would be difficult to see if Earth were reduced to the size of a globe held in the hand. Mountains seem to rise boldly from this surface, asserting mass and permanence, yet even the tallest ranges are shallow features. Their peaks reach upward, their roots press downward, but both motions remain confined to the outermost skin. They do not pierce the planet, they do not reach its heart. They simply wrinkle the surface, slow deformations produced by forces far larger and deeper than the shapes they create. Below this skin begins a realm defined not by air or stone as we know them, but by pressure and heat accumulating steadily with depth. The materials change their behavior long before they change their identity. Solidity becomes conditional, rigidity softens. What seems fixed begins to move, not suddenly, but patiently, over spans of time too long for direct perception. This motion carries continents, shapes basins, and closes fractures that briefly open before sealing themselves again. Nearly all of Earth exists below the reach of light, weather, and direct observation. The volume hidden beneath the crust holds almost all of the planet's mass. It generates the heat that escapes upward. It drives the slow circulation that reshapes the surface without urgency or intention. Humanity lives not on the body of the planet, but on its boundary with space, dependent on processes unfolding far beneath without ever encountering them. This imbalance between where life exists and where Earth truly resides defines our relationship with the planet. We touch only the outermost edge. We sense motion indirectly through earthquakes, uplift, and the quiet rearrangement of landscapes over generations. What lies beneath supports everything, yet remains distant, not hostile, not secretive, simply beyond the scale where human presence can follow. The ground beneath our feet feels complete because it is all we know. In reality, it is only the beginning. Long before depth became abstract, it was marked carefully in meters, recorded line by line as steel descended into stone. The effort unfolded slowly, season after season, not as a dramatic plunge, but as a patient negotiation with the planet. Each addition of depth felt earned, measured against time rather than ambition, as though the earth itself set the pace. The Kola Superdeep borehole stands as the farthest physical reach ever achieved beneath the surface. It did not descend toward fire or molten rock, but into something far stranger, an environment where expectations began to loosen their grip. What engineers encountered was not the solid immobility they had prepared for, but rock behaving less like a barrier and more like a reluctant fluid. Under increasing heat, familiar materials lost their reliability, not because they shattered, but because they softened, twisted, and refused to remain stable. Progress slowed as temperatures rose far faster than predictions allowed. Instruments warped, drill bits dulled and failed, lubricants broke down, electronics grew unreliable. The challenge was never a single dramatic obstacle, but an accumulation of small refusals, systems no longer able to operate as designed. Every additional meter demanded more energy, more reinforcement, more patience, until effort and reward drifted out of balance. The distance achieved was astonishing by human standards, yet modest when held against the planet's scale. Decades of work reached only a narrow incision into the crust, a depth smaller than the width of many cities resting far above it. This was not a failure of commitment or ingenuity. It was a lesson written slowly into steel and stone, revealing that downward travel obeys rules very different from those that govern movement across land or water. What stopped the descent was not an impenetrable layer or a sudden boundary, but heat accumulating quietly with depth. As temperatures climbed, rock strength diminished in unexpected ways. Walls closed in, open space became temporary. The borehole itself began to heal, narrowing as if the planet were gently reclaiming the intrusion. Keeping the path open required constant intervention, and eventually even that was no longer enough. When drilling ceased, the decision felt less like surrender and more like recognition. The Earth had not blocked the attempt through force, but through conditions incompatible with human machinery. The experiment had reached a natural conclusion, defined not by depth alone, but by the limits of materials shaped for cooler, gentler environments. What remained was knowledge earned through restraint, data gathered from pressure, temperature, and sound traveling through the rock offered glimpses of processes unfolding far below. The borehole became not a passage, but a listening point, a reminder that physical presence is not always required for understanding. The deepest descent ever made did not reveal the center of the planet. It revealed the quiet truth that reaching inward demands a different relationship with scale, time, and endurance than humanity has yet achieved. Distance downward feels deceptively ordinary at first, measured in familiar increments, each meter resembling the last. Yet beneath that steady arithmetic, conditions shift far faster than intuition allows. Depth is not a simple extension of space. It is an acceleration, where several forces rise together, quietly reinforcing one another until progress changes meaning. Heat does not wait patiently underground. It accumulates with intent, drawn from the planet's interior and pressed upward through layers of rock. With every descent, temperature increases, not as a gentle gradient, but as a tightening presence. Materials designed for surface conditions begin to lose their certainty. Metals soften, lubricants thin. Precision fades as tolerances narrow. The environment grows less forgiving long before depth seems extreme. Pressure builds alongside heat, though its influence is harder to imagine. Above ground, weight disperses into open air. Below, mass stacks relentlessly, each layer adding its burden to everything beneath it. This pressure does not announce itself through sudden collapse. Instead, it alters how matter behaves. Cavities resist remaining open. Stress flows through solid ground, redistributing itself in slow, deliberate motion. Together, heat and pressure reshape rock at a fundamental level. What once fractured cleanly under force begins to respond differently. Cracks refuse to propagate. Surfaces press together instead of separating. Rock that appeared rigid adopts a subtle flexibility, bending and creeping rather than breaking. The boundary between solid and fluid blurs, not into melt, but into something intermediate, patient and persistent. Drilling relies on brittleness, on the ability of material to fail in predictable ways. Bits bite, fragments shear off, debris is carried upward, and empty space remains behind. At depth, this relationship dissolves. The rock absorbs energy without yielding. Walls close inward. Voids shrink. Progress becomes temporary, constantly undone by the environment itself. This is why depth outpaces distance. Every additional meter compounds multiple challenges at once. Heat undermines equipment. Pressure reshapes structure. Rock behavior shifts away from cooperation. Solutions that work near the surface lose relevance, not because of poor design, but because the conditions they depend upon no longer exist. The Earth does not present a single barrier at depth. It presents a convergence where many subtle obstacles align. None are dramatic alone. Together, they define a limit that arrives sooner than expected. The planet's interior is not defended by hardness alone, but by an environment that steadily erases the assumptions of surface engineering. As depth increases, the task transforms. The act of drilling ceases to be an extension of surface work and becomes a negotiation with processes that move slowly, relentlessly, and without regard for human timescales. Space itself becomes unstable, briefly opened and then reclaimed. What seems like a short descent on paper becomes, in reality, an encounter with a different set of physical rules. Distance remains measurable. Feasibility quietly slips away. There is a moment where familiar rules loosen without ceremony. No boundary is crossed. No signal announces the change. Stone that once answered force with sharp breaks begins to respond more slowly, as though time itself has been mixed into it. The ground remains solid by name, yet its behavior drifts, and certainty thins with every step downward. Deep within the planet, rock exists under conditions far removed from the surface world. Heat saturates it. Pressure presses from every direction at once. In this environment, rigidity becomes optional. Crystals slide past one another, grains realign. What once held its shape now reshapes itself quietly, not through collapse, but through persistence. Motion appears without travel, change without fracture. This slow movement is not fluid in the way water is known, yet it is no longer fixed. It creeps, it bends, it absorbs force, and releases it over spans that defy observation. The distinction between solid and liquid grows indistinct, replaced by a spectrum where material chooses patience over resistance. Rock flows without spilling, yielding without breaking. For tools designed to cut and clear, this transformation alters everything. The assumption that material will fail cleanly no longer holds. Effort does not produce separation. Pressure applied returns as pressure received. Openings refuse to remain open. Any space carved into the earth becomes temporary, subject to gradual closure as the surrounding material presses inward with unhurried certainty. This behavior is not hostile. It is simply consistent with the conditions present. At depth, energy prefers redistribution to release. Stress migrates rather than snapping. Deformation replaces fragmentation. The planet adjusts itself continuously, smoothing disruptions as they arise, reshaping without the urgency familiar to surface processes. As rock transitions into motion, the environment becomes less a place and more a process. Boundaries blur, structures lose permanence. The idea of excavation itself begins to dissolve, not because the ground is impenetrable, but because it refuses to stay still. What is gained through effort is slowly reclaimed through balance. In this realm, movement belongs to the earth alone. Human methods depend on moments, on brief instants where change can be forced and held. At depth, time stretches. Material answers on its own schedule. The planet does not resist entry through strength or speed, but through a gentler persistence that outlasts intervention. What remains is a recognition written into the stone itself. Solidity, as experienced at the surface, is a local condition. Beneath it lies a world shaped by motion so slow it appears invisible, yet so steady it redefines what ground truly is. Heat announces itself long before depth feels dramatic. It does not roar or flash, but settles in quietly, filling space that cannot be emptied. As descent continues, warmth becomes a constant presence, seeping through metal and stone alike, indifferent to effort or intention. This is not surface heat shaped by sun or season. It is a deeper energy rising steadily from within the planet itself. Far below, heat is generated without flame. Radioactive elements embedded in rock release energy as they slowly decay, a patient process unfolding over billions of years. Alongside this, immense warmth remains trapped from the planet's formation, lingering from an era when Earth was still assembling itself. These sources combine, creating a background temperature that increases with every step inward, not as an anomaly, but as a fundamental condition. Machines can be built to endure pressure. They can be reinforced against weight and stress. Heat is less accommodating. Cooling systems rely on contrast, on the ability to move warmth away from sensitive components into a colder surrounding environment. Underground, that contrast fades. The rock itself radiates energy inward. Heat arrives from all directions at once, filling every cavity, saturating every surface. As temperature rises, the margin for control narrows. Coolants absorb energy until they can carry no more. Circulation slows. Balance becomes unstable. Efforts to remove heat begin to feel like attempts to empty a vessel that is being refilled continuously. The deeper the descent, the less meaningful cooling becomes, until management turns into delay rather than solution. Electronics suffer first. Precision depends on stability, on signals traveling cleanly through carefully arranged pathways. Heat distorts those pathways. Resistance changes. Timing drifts. Circuits misread their own states. Long before metal softens or structures deform, the invisible logic that guides machines begins to unravel. Instruments lose trust in their readings. Systems shut down not in failure, but in self preservation. This breakdown happens quietly. There is no singular point of collapse. Instead, reliability erodes. Components behave unpredictably. Maintenance intervals shrink. The environment does not allow pauses. Heat continues its steady advance, indifferent to whether machines are active or idle. What makes this barrier so enduring is its inevitability. Heat cannot be drilled through or pushed aside. It does not crack or yield. It accumulates. Any attempt to reach greater depths must exist within it, endure it fully, or not proceed at all. There is no corridor where warmth briefly recedes, no pocket of relief waiting below. At a certain point, heat defines the environment entirely. Materials cease to be chosen for strength alone and are instead judged by how long they can tolerate saturation. Operation becomes temporary by nature. The planet does not oppose intrusion with violence, but with a steady presence that cannot be negotiated. Pressure is not sensed underground as weight alone. It arrives as presence, quiet and total, filling every direction at once. Unlike the pull of gravity at the surface, which presses downward and then disperses, deep pressure has nowhere to go. It accumulates, layer upon layer, until space itself seems to tighten. What surrounds a material becomes as influential as the material itself. As depth increases, pressure multiplies far beyond anything encountered above ground. Millions of times greater than surface conditions, it reshapes the internal structure of matter without leaving visible marks. Atoms are forced closer together. Bonds behave differently. Subtle changes cascade into larger consequences, altering how substances respond to stress, heat, and time. The familiar relationship between force and resistance begins to dissolve. Metals, trusted for their strength and resilience, respond in unexpected ways. Under extreme pressure, they do not simply compress, they warp internally. Crystal lattices shift. Weak points emerge where none were anticipated. A material that performs flawlessly in open air can lose coherence when surrounded by immense weight. Its ability to bear load becomes inconsistent, dependent on factors that surface testing never reveals. Strength, once measured reliably, no longer scales in a straight line. Thicker does not always mean stronger. Harder does not always mean safer. Pressure alters failure modes, encouraging slow deformation instead of sudden breakage. Components bend imperceptibly. Shapes distort over time. What appears stable may already be changing, yielding in ways that only reveal themselves after function has been compromised. Even the most advanced alloys, designed for extremes, face uncertainty. Their limits are not crossed abruptly, but approached gradually, marked by growing unpredictability. Tolerances shrink, safety margins blur. Engineers are left working within environments where reliability becomes statistical rather than assured. Each decision carries assumptions that pressure quietly undermines. This transformation does not announce itself through dramatic collapse. Instead, it reveals itself through inconsistency. Materials behave as expected one moment, then deviate the next. Measurements drift. Structural models lose accuracy. The ground exerts influence not through motion, but through omnipresence, shaping every interaction from the outside in. As pressure rewrites behavior, it also rewrites intention. Tools designed to impose force find that force redistributed before it can be applied. Effort returns altered, softened, or redirected. Control becomes difficult to maintain, not because of fragility, but because the environment itself participates in every exchange. In such conditions, material choice becomes provisional. No substance remains dependable indefinitely. Reliability fades, not due to flaw or fatigue, but because the rules governing strength have shifted. Pressure does not oppose exploration with resistance alone. It changes the meaning of resistance itself, quietly redefining what it means for matter to endure. Descent follows gravity with a kind of quiet permission. Moving downward aligns with the natural direction of force, allowing pressure to accumulate without interruption. Materials compress as expected. Structures adjust gradually. The environment closes around the intrusion, but it does so evenly, without demanding immediate response. Going down becomes an act of accommodation, a slow agreement with the conditions already present. The return is different. As ascent begins, pressure releases instead of building. What was once balanced becomes unstable. Materials that adapted to immense weight are suddenly asked to expand, to separate, to remember forms they held far above. This change happens faster than internal structures can accommodate. Stress appears where none existed before, not from compression, but from relief. Samples collected at depth carry the memory of where they formed. Their crystals align under pressure. Their chemistry settles into arrangements that depend on constant force. When that force diminishes, those arrangements weaken, fractures open, gases escape, minerals change phase. What was stable below begins to alter during the journey upward, reshaping itself in response to the absence of weight. This transformation is not violent. It unfolds quietly, within the material itself. Fine cracks spread, surfaces craze, textures soften or stiffen unpredictably. In some cases, the very act of retrieval erases the conditions scientists hope to study. The sample arrives at the surface intact in appearance, yet fundamentally changed, no longer a faithful record of its origin. Containment offers only partial protection. Pressure vessels can slow the transition, but perfect isolation remains elusive. Seals flex, temperatures shift, time passes. Even small deviations allow internal processes to resume, undoing the balance held below. The journey becomes an extended moment of exposure, where information leaks away gradually rather than all at once. Recovery, then, becomes a second descent, not into depth, but into uncertainty. The effort invested in reaching extreme conditions does not guarantee that those conditions can be carried back. Knowledge gathered below risks unraveling during ascent, altered by forces moving in the opposite direction. What arrives is not always what was encountered. This asymmetry defines much of deep exploration. Entry aligns with planetary gradients. Exit works against them. Systems designed to endure compression struggle with expansion. Materials, shaped by pressure, resist release. The path upward proves narrower, more fragile, constrained by transformations that cannot be paused. In this way, understanding collapses not because it was unreachable, but because it was transient. Depth allows observation under specific conditions. The return demands translation into a world where those conditions no longer exist. Between the two lies a passage where certainty thins, and the earth quietly reclaims the information it briefly allowed to be touched. Long after physical descent slowed and then stopped, motion continued beneath the surface without pause. The planet never rests, even when it resists entry. Energy moves constantly through its body, released not by tools or intention, but by the slow rearrangement of vast structures deep within. This motion carries information outward, reaching places where no drill can follow. Earthquakes are among the few processes that travel freely through the planet. When faults slip and plates adjust, energy radiates in all directions, rippling outward as waves that pass through layers unseen. These vibrations are not uniform. They stretch, compress, slow, and bend as they encounter different materials. Each encounter leaves a subtle imprint, a change in timing or shape that carries meaning. As these waves move, they respond to density, temperature, and composition. Some pass quickly through rigid regions and hesitate in softer ones. Others vanish entirely, unable to exist in certain environments. The planet reveals itself through these variations, not directly, but through contrast. What cannot be touched begins to announce itself through pattern. Scientists learn to listen carefully to these signals. Instruments placed far from the source record the arrival of waves, noting their sequence and delay. Over time, a language emerged. Speeds suggested solidity. Absence suggested fluidity. Reflections hinted at boundaries buried far below any reachable depth. The Earth, though inaccessible, became readable. This shift marked a quiet turning point. Exploration no longer depended on cutting into the ground. It relied instead on patience and interpretation. The planet offered glimpses of its interior through its own motion, through events that occurred whether humans observed them or not. What was needed was attention, not penetration. Listening proved gentler than drilling. It did not disturb the layers being studied. It asked nothing of the environment beyond what it already gave freely. Earthquakes, unpredictable and immense, provided natural probes that reached from crust to core and back again, carrying signatures of every region they passed through. Through careful study, layered structures began to take shape. Boundaries once imagined became clearer. The division between outer and inner regions emerged not as lines on a map, but as changes in behavior. Waves bent here. They slowed there. Some vanished at certain depths, reappearing farther on, transformed by what they encountered. This method required acceptance of distance. It acknowledged that some places could not be visited, only inferred. Understanding grew not from presence, but from relationship. The earth communicated through vibration, and humans learned to translate its replies. By turning away from drills and toward listening, exploration adapted to reality rather than resisting it. The planet did not open itself through force. It revealed itself through motion already underway. Knowledge arrived not as conquest, but as resonance, shaped by waves passing endlessly through a world that could not be entered, yet could still be known. The planet speaks most clearly when it is not being approached. Its deepest structures announce themselves through motion rather than form, through subtle signals traveling vast distances without ever slowing enough to be seen. These signals move as vibrations, spreading outward from distant fractures and adjustments, carrying with them the imprint of every layer they cross. Not all seismic waves behave the same way. Some move by compressing and expanding the material they pass through, pressing forward like a pulse. Others travel by shifting matter side to side, producing motion without compression. Each type responds differently to the conditions below, and in those differences, the interior begins to take shape. As waves descend, they encounter environments that alter their paths. Density changes redirect them. Temperature influences their speed. Composition determines whether they pass through unhindered or struggle to continue. Some waves slow gradually, stretching their arrival times. Others curve, bending as though guided by invisible contours deep within the planet. Their trajectories trace the hidden architecture of the Earth. Certain waves cannot exist everywhere. When they reach regions where material behaves differently, they simply disappear. Their absence becomes meaningful. A missing signal marks a change more clearly than a visible one. It suggests a boundary that cannot be crossed in the same way, a region where familiar behavior no longer applies. Through these silences, scientists learned to recognize layers that could not be touched. Other waves reflect, rebounding from interfaces buried far below the surface. They return altered, carrying the timing and angle of their encounter back upward. These echoes are measured patiently, recorded by instruments tuned to motions smaller than the width of an atom. Over time, patterns emerge, distances are inferred, depths are estimated, shapes begin to form without ever being seen. The planet reveals itself through contrast rather than exposure. Where waves change speed, something has changed. Where they bend, something resists. Where they vanish, something fundamental differs. These reactions outline boundaries more clearly than any direct image could, defining regions not by what they contain, but by how they respond. This method does not require proximity. It depends on listening from afar, on allowing the earth to move as it always has, and studying the traces of that movement. Vibrations pass through crust, mantle, and deeper realms alike, sampling every condition along their paths. Each journey adds another piece to a picture assembled slowly across decades. Through this steady accumulation, the interior became layered and ordered, not as a solid mass, but as a dynamic body with changing properties. The planet's depths emerged not as a destination, but as a pattern of behaviors woven together by motion. What cannot be reached by machines becomes known through resonance. The Earth offers no window into its center, yet it sends continuous messages outward. In the bending of waves and the quiet spaces they leave behind, the unseen becomes legible, shaped not by presence, but by how motion is shaped in return. Patterns began to surface long before names were assigned to what lay beneath. They emerged quietly, from records spread across continents, from traces of motion arriving sooner or later than expected. Each signal carried slight differences, small deviations that gained meaning only when gathered together. Over time, those deviations stopped appearing random. They formed structure. As seismic waves traveled through the planet, their paths refused to remain uniform. Some slowed abruptly, as if encountering resistance. Others bent smoothly, curving away from straight lines that logic alone would predict. These behaviors clustered at similar depths, repeating across unrelated events. The Earth was responding consistently, revealing internal divisions not through visibility, but through reaction. One of the most profound revelations came from noticing that depth did not behave as a continuous gradient. Instead of gradual change, there were transitions. At certain levels, wave behavior shifted noticeably, as if crossing invisible thresholds. Density increased suddenly. Speed altered sharply. Motion that flowed freely above encountered constraints below. These transitions mark the presence of vast internal regions. The mantle emerged not as a uniform mass, but as a distinct domain, defined by how it shaped the passage of energy. It occupied a volume far greater than the crust, yet remained unreachable, known only through its influence. Seismic waves passing through it bent and slowed in ways that differed from anything observed closer to the surface. Its presence reshaped expectations of what lay beneath familiar ground. Deeper still, additional boundaries appeared. Some waves reflected cleanly, returning signals that suggested firm separations. Others vanished and reappeared beyond certain depths, transformed by encounters with material unlike anything above. These behaviors implied layers with properties that could not coexist, regions defined less by composition alone and more by how they handled motion. Through this evidence, Earth's interior began to look less like a gradual descent and more like a series of chapters, each governed by its own rules. Depth ceased to mean distance alone. It became a measure of change, a progression through environments that differed fundamentally from one another. Going deeper no longer implied more of the same, but entry into something qualitatively new. This understanding reshaped how the planet was imagined. Instead of a solid sphere warming steadily toward the center, Earth appeared as a layered system, structured by pressure, temperature, and composition interacting in complex ways. Each layer carried its own identity, influencing the layers above and below through slow exchange and long balance. No image confirmed these discoveries. No sample verified them directly, yet consistency across countless observations gave them weight. The unseen became reliable through repetition. The absence of sight did not weaken understanding. It strengthened it by forcing attention to behavior rather than appearance. Through listening, the planet revealed itself as organized, dynamic, and internally diverse. Layers no one had ever seen became foundational to understanding Earth as a living system of motion and change. Depth transformed from a measure of how far down one could go into an expression of how many worlds existed beneath the surface. Beneath the surface, certainty of continents lies a region defined by patience. Nothing there rushes, and nothing there rests completely. The mantle exists in a state that resists simple description, appearing firm when touched briefly, yet reshaping itself when given time enough to matter. It is not a place of sudden change, but of motion stretched across ages. On human timescales, the mantle behaves as solid ground. It transmits seismic waves cleanly. It holds structure. It resists immediate deformation. A passing vibration feels its rigidity, carrying energy across immense distances without dissolving. To short observation, it seems fixed, reliable, and immovable, much like the crust above it. Time alters that impression. Given millions of years, the mantle responds differently. Under constant heat and pressure, its material yields slowly, grain by grain, allowing movement that never announces itself in a moment. This flow is not liquid motion. It does not pour or splash. Instead, it creeps. It rearranges internally, redistributing mass through gradual adjustment rather than visible travel. This long motion shapes everything above it. The slow circulation of mantle material transfers heat upward and sideways, creating forces that the rigid shell cannot fully ignore. Continents drift without awareness, carried atop processes unfolding far below their reach. Oceans widen, mountains rise and erode. What appears stable at the surface traces its origins to movement happening deep and unseen. Earthquakes, too, draw energy from this quiet engine. Stress builds where mantle motion meets resistance, pressing against the brittle crust. Over time, strain accumulates, not from sudden force, but from steady insistence. When release finally occurs, it is abrupt at the surface, yet deeply rooted in processes that have been unfolding patiently for ages. The mantle occupies a strange position in the planet's identity. It is neither foundation nor surface, neither static nor fluid. It connects deep heat to surface motion, acting as a mediator between extremes. Without it, energy would remain trapped below, and the outer shell would grow rigid beyond renewal. With it, The planet remains active, reshaping itself without haste. This movement is invisible in real time. No marker traces its path. No boundary shifts quickly enough to observe directly. Yet its influence is written everywhere, in the alignment of mountain chains, in the matching edges of distant continents, in the pattern of earthquakes that outline plates like faint echoes. The mantle does not flow in spite of being solid. It flows because solidity, under extreme conditions, becomes flexible when measured against time vast enough to matter. Strength does not vanish. It transforms, allowing motion to occur without collapse. Beneath the rigid shell we inhabit, this slow engine continues its work. It carries heat, redistributes mass, and shapes the planet quietly. The ground feels still because the motion beneath it moves on a timescale large enough to hold whole histories, turning the Earth without ever appearing to turn at all. There is a depth where continuity breaks without warning. The descent does not gradually fade into difficulty. Instead, it meets a boundary that feels decisive, a transition written into the planet long before tools existed to approach it. This boundary does not announce itself with spectacle, yet it ends every attempt to go farther. The crust-mantle boundary marks a sharp shift in conditions. Above it, rock behaves in ways that remain marginally compatible with mechanical effort. Below it, the environment reorganizes itself. Composition changes, density rises abruptly. Materials that once responded predictably begin to answer force with resistance that no longer resolves into progress. Temperature increases rapidly across this boundary. Heat that had been rising steadily suddenly concentrates, saturating the surrounding material. The rock carries this warmth continuously, radiating it inward and outward with equal persistence. Any structure brought here is exposed from all sides, unable to find relief through conduction or circulation. The margin between operation and failure narrows to nearly nothing. Pressure compounds alongside heat, reinforcing its effects. Mechanical components, designed to endure stress, now face conditions that undermine their function simultaneously. Metals lose rigidity faster than expected. Bearings seize. Cutting surfaces dull almost immediately. Motion becomes inefficient, then impossible, not through collapse, but through loss of cooperation between tool and environment. Drilling depends on contrast. It requires material that resists briefly, then yields, leaving space behind. At this boundary, that contrast disappears. Rock no longer fractures cleanly. It absorbs force and redistributes it, closing openings as quickly as they are formed. Any void becomes temporary, erased by surrounding motion and weight. This is not a single obstacle, but a convergence. Heat erases tolerance. Pressure reshapes behavior. Material properties shift away from brittleness entirely. Together, these changes remove the assumptions drilling relies upon. Effort no longer accumulates toward depth. It disperses, returning to the planet as heat and deformation without advancing position. Beyond this point, access ends not because the mantle is hidden, but because it cannot be entered by physical means. The boundary enforces a limit defined by physics rather than ingenuity. No improvement in cutting edge or structural strength alters the underlying conditions that prevail here. Progress ceases not gradually, but decisively. What lies beyond remains intact, unmarked by human contact. The mantle continues its slow motion, exchanging heat and mass on timescales vast enough to ignore brief intrusion. The boundary holds steady, not as a wall built against exploration, but as a line where the nature of matter itself changes. This depth does not forbid knowledge, it forbids presence. Mechanical descent reaches its natural conclusion here, where the planet's interior begins to operate according to rules no tool can satisfy. From this boundary inward, understanding must arrive without contact, carried instead by motion, vibration, and inference, leaving the mantle untouched and unreachable beneath the end of all drilling. Sometimes, the planet sends fragments of itself upward without intent. They arrive not through careful extraction, but through rupture, carried by forces that do not pause to preserve what they move. Volcanoes become pathways not by design, but by pressure seeking release, lifting material from depths that cannot otherwise be reached. Magma rising toward the surface originates far below the crust, drawing from regions shaped by heat and time rather than air and weather. Along its ascent, it gathers pieces of its origin, crystals formed under immense pressure, chemical signatures locked into structure. These materials travel quickly, faster than any drill could descend, crossing boundaries that normally remain closed. Yet the journey alters them immediately. As magma approaches the surface, pressure drops sharply, temperatures shift, gases expand. What formed in stability below must adapt to rapid change. Minerals begin to transform, structures reconfigure, some elements escape entirely, leaving behind incomplete records of their original state. When lava finally cools, it solidifies under conditions vastly different from those that shaped it. Crystals that once existed in balance adjust to new environments. Chemical ratios freeze into place, preserving traces while obscuring others. What reaches the surface is not the mantle as it exists below, but a version altered by ascent, pressure release, and cooling. These fragments offer hints rather than clarity. They suggest compositions. They imply processes. They reveal that the mantle is not uniform, that it carries variation shaped by depth, temperature, and movement. Yet every sample arrives changed, filtered by the violence of its journey. Interpretation requires caution, an understanding that the message has been distorted by the path it took. Some minerals, resilient and slow to react, preserve more of their deep history. They act as time capsules, holding isotopic signatures that speak softly of formation conditions far beneath the crust. Others respond quickly, resetting their internal clocks during ascent. The record becomes uneven, a mix of memory and adaptation. Through comparison and repetition, patterns emerge. Samples from different volcanoes hint at shared origins or distinct regions within the mantle. Variations point toward circulation, mixing, and long separation. Still, these insights remain partial. No eruption delivers a full picture. Each offers a glimpse shaped by chance. Volcanoes were never meant to be windows. They are expressions of imbalance, not invitations to observe. That they carry information at all is incidental. The mantle does not present itself willingly. It allows fragments to escape when conditions align, leaving surface observers to piece together meaning from what survives the transition. Most of what lies below remains inferred rather than known. Chemistry is reconstructed through models, movement deduced through behavior, structure suggested by indirect signals. Volcanic messengers add texture to that understanding without completing it. They remind us that the planet sometimes speaks through disruption, offering clues without explanation. What rises from depth arrives altered, incomplete, yet still valuable. In these accidental messages, the Earth reveals just enough to suggest its complexity, while keeping the greater story moving slowly beneath our feet. Beyond reach and beyond direct sight, there comes a depth where the planet no longer offers fragments of itself upward. Motion continues, heat circulates, pressure persists, yet nothing breaks free. Below the mantle, the pathways that once carried material toward the surface simply cease to exist. The earth grows inwardly complete, no longer interrupted by ascent or escape. In this deeper realm, matter settles into long equilibrium. Layers press together without faulting open. Stress redistributes smoothly instead of tearing rock apart. The forces that create fractures above lose their effect here, absorbed and balanced before cracks can propagate. The planet does not resist by force. It resolves imbalance before rupture can occur. No natural process lifts material from these depths. Volcanoes draw from higher regions, tapping zones where melt can still separate and rise. Below that, conditions eliminate separation itself. Density increases. Pressure confines movement inward and sideways rather than upward. Buoyancy fades as a driving force. Any difference that might encourage ascent is quietly erased. The planet seals itself through patience rather than rigidity. Over immense spans of time, internal motion smooths irregularities, closing openings before they widen. Where the mantle still circulates, deeper layers remain continuous, locked into behavior governed by pressure so immense that disruption becomes improbable. The earth maintains coherence without stillness. This closure marks a profound boundary. Above it, fragments can escape, signals can travel outward. Below it, interaction becomes indirect entirely. No crack forms an invitation. No pathway lingers long enough to be used. The interior becomes isolated, not by distance alone, but by a change in how matter behaves under extreme conditions. From this point onward, exploration can no longer rely on samples or contact. Observation shifts fully into abstraction. What lies deeper must be understood through inference, through the behavior of waves, gravity, and magnetic fields interacting with unseen structures. Knowledge becomes dependent on models refined by consistency rather than confirmation. These theoretical spaces are not imagined freely. They are constrained by evidence arriving from afar, by patterns that cannot be ignored. Still, the absence of physical access changes the nature of understanding. The deepest regions are known only through their influence, never through encounter. This inaccessibility is not temporary. No improvement in engineering alters the balance here. Conditions do not fluctuate toward openness. The planet's interior remains closed on human timescales, sealed by forces that move too slowly and too completely to permit intrusion. The Earth keeps its deepest structure intact. What exists below continues its quiet processes without interruption. Heat flows, material adjusts, fields arise and persist. These motions shape everything above while remaining untouched themselves. The surface world responds to influences that originate far beyond reach, guided by regions no tool has ever marked. At this moment, Earth becomes inaccessible, not as a challenge, but as a fact. The path inward ends. Understanding proceeds without entry, carried by patience, mathematics, and listening. The planet remains whole, its deepest story unfolding beyond presence, complete without ever being touched. At the greatest depths, motion begins to misbehave. Signals that once traveled reliably arrive altered, delayed, or changed in form, as though the planet itself has softened the rules they once followed. These changes were subtle at first, easy to overlook without patience. Over time, they gathered into something unmistakable. Seismic waves that pass cleanly through solid regions begin to falter far below the mantle. Some slow dramatically, others bend more sharply than expected. A few vanish altogether, not scattered or weakened, but absent, leaving gaps where motion should have arrived. These absences repeat consistently across events separated by oceans and generations, forming patterns that resist coincidence. The disappearance of certain waves carried quiet significance. Some forms of vibration depend on rigidity. They require a structure capable of restoring shape after deformation. When those waves failed to arrive, it suggested that somewhere deep below, rigidity no longer applied. The Earth was no longer responding as a solid body alone. This realization did not come from sight or sample, but from silence. Where expected motion did not appear, a new environment was implied, a region where material yielded differently, a place where compression traveled, but shear did not. The behavior pointed toward liquid properties hidden beneath immense pressure. This liquid was not imagined as flowing freely. It existed under forces so great that motion remained constrained. Yet its inability to support certain vibrations marked a profound shift. Beneath solid rock, a layer behaved as a fluid on seismic terms, reshaping understanding of what lay at the planet's center. Further analysis refined the picture. Some waves passed through this region, but emerged altered, bent by transitions between states. Others reflected off boundaries that could only exist between unlike materials. Timing differences revealed size. Bending paths hinted at shape. Absence defined presence more clearly than any direct signal could. Through these behaviors, the core took form in the collective understanding. It was not discovered as an object, but as a response. Its properties were described through how energy moved, slowed, vanished, or returned. The Earth revealed its deepest structure not by offering access, but by shaping motion around it. This knowledge required trust in inference. No confirmation arrived from touch or sight. Consistency replaced certainty. When silence appeared where sound should be, it spoke with unexpected clarity. Each missing wave narrowed possibilities, refining models built on restraint rather than assumption. Over time, distinctions emerged within the core itself. Variations in wave behavior suggested differences in state, regions responding separately to immense pressure and heat. Yet all of this understanding remained indirect, layered through interpretation, anchored in patterns rather than proof. The core became real through behavior alone. Its existence was defined by influence, not exposure. It shaped the planet's magnetic presence, guided deep circulation, and anchored internal structure without ever being reached. In this way, the Earth offered its deepest truth through absence. The silence of missing waves became a form of evidence, allowing the core to be known without being touched, present through the way it refused to let certain motions pass. Movement continues at the planet's heart without ever inviting entry. Beneath layers that resist touch and fracture, the outer core exists as a realm defined by motion alone. It cannot be reached, sampled, or observed directly, yet its influence extends outward, shaping conditions far above its hidden depth. The outer core is understood as a vast body of liquid metal, primarily iron, mixed with lighter elements, held in constant motion by heat and rotation. This motion is not chaotic. It follows patterns guided by the planet's spin and the flow of energy escaping from deeper regions. Currents rise and fall slowly, twisting and looping through a space where pressure prevents vapor and heat prevents solidity. Within this motion, electricity emerges. As conductive fluid moves through existing magnetic influence, It strengthens and reshapes that influence in return. The result is a self-sustaining process, a quiet engine that converts internal motion into a planetary field. This field stretches outward into space, invisible yet present, bending charged particles and guiding radiation away from the surface. Life above depends on this unseen activity. The magnetic field shields the atmosphere from gradual erosion, preserving the air that carries sound and breath. It softens the impact of solar wind, allowing water to remain and chemistry to unfold slowly rather than being stripped away. The surface feels calm because of motion occurring far below, separated by thousands of miles of inaccessible depth. Despite its importance, the outer core remains unreachable. No crack descends into it. No eruption draws material upward from its depths. The same conditions that allow liquid metal to exist also prevent ascent. Density overwhelms buoyancy. Pressure eliminates pathways. The planet's structure directs movement sideways and around, not upward and out. Knowledge of this region arrives indirectly. Variations in seismic waves suggest fluid behavior. Changes in wave speed and disappearance reveal boundaries consistent with liquid properties. Fluctuations in the magnetic field hint at shifting currents below, responding to forces we cannot observe directly. Each piece of evidence arrives separately, yet aligns into a coherent picture. The outer core is not imagined freely. Its description is constrained by behavior that repeats reliably. Magnetic reversals leave traces in ancient rock, recording changes in direction over time. These records point back to the same hidden source, reinforcing the idea of a dynamic interior shaping long spans of planetary history. Still, the outer core remains distant in a fundamental way. It does not resist exploration. It simply exists under conditions incompatible with approach. Temperature, pressure, and composition converge to form an environment that supports motion while denying access. The boundary holds steady, not through rigidity, but through balance. This region demonstrates a different kind of presence. It cannot be visited, yet it acts continuously. It shapes the world without revealing itself. The outer core stands as an example of influence without contact, motion without entry, a reminder that some of the most vital processes on Earth unfold where humans will never stand, guiding life quietly from beneath the limits of reach. Stability on the surface is sustained by motion far below it. The planet's long endurance does not arise from stillness, but from activity hidden beyond reach. Beneath layers that resist entry, an engine continues its work, shaping conditions that allow oceans to remain, air to persist, and time to stretch gently across the surface without sudden loss. This engine operates without pause. Movement within the deep interior regulates flows of energy that would otherwise accumulate unevenly. Heat is redistributed slowly rather than released all at once. Fields emerge that guide charged particles away from fragile layers of atmosphere. The surface world benefits from balance maintained well beyond its awareness. Over long spans, subtle changes in this deep motion ripple outward. Variations in internal circulation influence the strength and structure of the magnetic field, which in turn affects how radiation interacts with the planet. When the field weakens or shifts, more energy reaches the upper atmosphere. When it strengthens, shielding improves. These transitions occur gradually, unfolding over thousands or millions of years, yet their consequences shape the conditions under which life evolves. Climate responds quietly to this invisible partnership. Atmospheric retention depends on protection from constant solar pressure. Without it, Gases disperse, temperatures drift, and water becomes less stable. The deep engine does not set weather or seasons, but it holds the broader frame in place, preserving the environment in which surface processes can repeat reliably. Life depends on these hidden systems without ever encountering them. Cells adapt to sunlight filtered through magnetic shielding. Ecosystems develop under radiation levels moderated by distant motion. Evolution unfolds in a landscape made possible by forces that never surface, never fracture upward, never announce themselves directly. The importance of this unseen activity becomes clearer when viewed through absence. Where similar processes weaken on other worlds, atmospheres thin and surfaces grow exposed. Stability gives way to erosion by space itself. Earth remains hospitable not because its surface is protected by thickness alone, but because its interior remains active in exactly the right way. This activity is beyond visitation. No material carries a return address from those depths. No instrument approaches the source directly. Understanding arrives only through effect rather than encounter, through patterns measured far above their origin. The engine remains untouched, yet its influence is continuous. That distance lends it a strange permanence. Surface features rise and fall, continents drift, climates shift, yet the deep interior persists as a steady moderator, absorbing change and releasing it slowly enough to preserve coherence. Its motion is measured not in moments, but in eras. The planet is powered from a place that cannot be entered, yet cannot be ignored. The most important processes shaping habitability unfold where no observer can stand, guided by physics that operate patiently beyond reach. Life flourishes under the care of this hidden engine, sustained by motion that will never be visited, yet never ceases to matter. At the center of the planet, expectation fails quietly. The conditions there defy ordinary logic, not through spectacle, but through contradiction held in balance. The inner core exists where heat reaches extremes that would liquefy familiar matter, yet solidity persists, maintained by forces strong enough to rewrite behavior itself. Temperature in this region surpasses anything found naturally at the surface. Energy saturates every particle, encouraging motion and disorder. Under such conditions, melting would seem inevitable, and yet the inner core resists that fate. It holds shape not because it is cool, but because pressure outweighs temperature in the deepest competition of forces. Pressure at the planet's center is immense, beyond comparison. It presses inward from every direction, forcing atoms into proximity so close that movement becomes constrained. Bonds that would break under heat alone are reinforced by confinement. The material cannot expand, it cannot separate. Motion is limited to vibration rather than flow. The result is a solid formed not by cold, but by compression. This balance creates a state unfamiliar to surface experience. Here, solidity does not imply rigidity in the usual sense. It implies order enforced by weight. The inner core remains structured because there is nowhere for disorder to go. Heat excites motion internally, yet pressure prevents rearrangement. The material endures as a solid only because escape is impossible. This paradox reshapes how solidity itself is understood. On the surface, solids melt when temperature rises past a threshold. In the deep interior, that threshold shifts dramatically. Pressure alters phase boundaries, redefining what states matter can occupy. What would melt instantly above becomes stable below, preserved by confinement rather than cooling. No laboratory can recreate this environment fully. Pressure chambers approximate fragments of the condition, and experiments hint at behavior under extreme compression. But the precise combination of heat, time, and force at the planet's center remains unmatched. The inner core exists in a regime beyond replication, sustained by circumstances unique to planetary scale. Evidence of this solid state arrives indirectly. Seismic waves pass through the core and behave differently depending on what they encounter. Some speeds increase unexpectedly, suggesting rigidity. Reflections sharpen where boundaries should blur. These patterns imply a distinct region with properties unlike the surrounding liquid. The conclusion emerges from consistency, not observation. The inner core influences its surroundings through stillness as much as motion. Its solidity affects how the outer core circulates around it, guiding currents that contribute to larger magnetic behavior. It acts as an anchor, a stable presence within a moving system, shaping flow without participating in it. This strange solidity remains untouchable and unseen. It exists as a solution to competing forces, a structure maintained by the same pressure that forbids access. The inner core stands as one of the planet's quietest contradictions, a solid formed by heat, restrained by weight, enduring at the center of a world that cannot be entered, yet continues to define the Earth from within. Exploration often follows stability more than distance. Space appears hostile, yet it offers predictability. Conditions beyond the atmosphere are severe but consistent, allowing machines to be designed around known limits. Vacuum, radiation, and cold remain largely unchanged across vast regions. Once beyond Earth's pull, the environment settles into patterns that can be anticipated and managed. The planet's interior offers no such agreement. Conditions do not stabilize with depth, they intensify. Every descent introduces new variables, not as isolated challenges, but as forces that compound continuously. Heat rises without pause. Pressure multiplies without relief. Material behavior shifts repeatedly, denying any long-lasting equilibrium. In space, extremes exist in isolation. Temperature can be controlled through shade and exposure. Radiation can be shielded or predicted. Mechanical systems operate in an environment that, once entered, remains largely the same. The challenge lies in reaching orbit, not in surviving once there. Beneath the surface, survival depends on constant adaptation. No depth offers respite. There is no zone where conditions pause long enough to permit extended operation. Heat arrives from all directions. Pressure surrounds completely. Systems cannot be tuned to a single environment because that environment changes with every meter of descent. This continuous escalation erodes reliability. Materials selected for one depth lose suitability moments later. Cooling systems become temporary measures rather than solutions. Structural designs that endure briefly fail gradually as conditions outpace design assumptions. Progress does not accumulate. It resets repeatedly, erasing gains as the environment reshapes itself. Space exploration benefits from separation. The vacuum isolates spacecraft from external forces, allowing internal conditions to be maintained independently. Earth's interior allows no separation. The environment presses inward constantly, influencing every component and process simultaneously. Control cannot be isolated. It must be negotiated continuously. Time also behaves differently. In orbit, machines can operate for years within stable parameters. Beneath the surface, degradation accelerates. Heat alters chemistry. Pressure changes structure. Wear becomes environmental rather than mechanical. Even when motion stops, damage continues. The absence of a safe operating zone defines the challenge. There is no depth where conditions briefly stabilize, where machines can rest, recalibrate, or recover. Every pause allows heat and pressure to continue their work. Stopping does not preserve systems, it exposes them longer. Space allows retreat. A malfunctioning craft can adjust position or orientation. Beneath the surface, retreat requires retracing a path through increasingly hostile gradients. The return journey introduces new stresses as pressure releases and temperature shifts, often causing failure during ascent rather than descent. In this comparison, space becomes paradoxically gentle. Its dangers are vast but static. Earth's interior is intimate and relentless. It adapts nothing to human presence. It changes constantly, indifferent to intention or preparation. Exploration thrives where limits can be defined. Beneath the ground, limits move faster than understanding. The planet's interior remains harder to explore not because it is farther away, but because it refuses to hold still long enough to be met. Failure underground rarely arrives suddenly. It accumulates quietly, layer by layer, as conditions interfere with systems never meant to operate together for long. Robots descend carrying precision, logic, and calibration shaped by surface expectations. With depth, those assumptions erode. Electronics are the first to lose their footing. Heat seeps into circuits that depend on stable temperatures to preserve timing and signal clarity. Components drift out of tolerance. Resistance changes. Sensors begin to misread the world they were designed to interpret. What appears minor at first grows persistent, introducing uncertainty into every calculation. Decisions once made confidently become delayed or incorrect, not through error, but through distortion. Lubricants follow. Fluids meant to reduce friction thin and degrade as temperatures rise. Some evaporate, others thicken unpredictably. Bearings grind instead of glide. Joints stiffen, then loosen, then seize. Motion becomes inefficient, wasting energy and increasing wear. What was once smooth becomes reluctant, then unreliable. The machine expends more effort simply to keep moving, leaving less capacity for purpose. As friction increases, structural fatigue accelerates. Materials experience stress from multiple directions at once. Heat expands components unevenly. Pressure compresses them. Vibration persists from drilling, movement, or surrounding motion. Microfractures form where tolerances were tightest. These flaws spread slowly, unseen, weakening the whole without a clear point of failure. Strength diminishes even as outward appearance remains unchanged. Autonomy depends on consistency. Robots require predictable relationships between input and response. Underground, those relationships collapse. Sensors deliver conflicting information. Actuators respond unevenly. Feedback loops struggle to stabilize when the environment shifts faster than software can adapt. Control systems compensate briefly, then overcorrect, then lose coherence. Communication compounds the problem. Signals weaken with depth. Delays increase. Machines become isolated, forced to rely on internal decision-making as external guidance fades. When internal systems are already compromised by heat and stress, independence becomes a liability rather than a solution. Small errors propagate unchecked. Maintenance, the quiet savior of surface robotics, becomes impossible. No component can be swapped. No recalibration can be performed. Degradation continues uninterrupted. Every moment spent operating also shortens remaining lifespan. Stopping offers no protection, since heat and pressure persist regardless of motion. Robots fail not because they are poorly built, but because the environment refuses to remain stable long enough for complexity to survive. Underground conditions act on every system simultaneously, eroding performance across electronics, mechanics, and logic at the same time. There is no single fix, only cascading limits. Depth magnifies time. Processes that would take years on the surface unfold in days or hours below. Reliability curves steepen, margins vanish. Machines designed for exploration encounter a domain where endurance matters more than capability. In the end, robots do not reach meaningful depth because meaning depends on sustained function. The planet's interior allows no such continuity. Precision fades, motion degrades, and autonomy dissolves, leaving machines quiet and incomplete, long before the depths they were sent to understand. Progress in materials science rarely arrives as a leap. It advances through refinement, through alloys strengthened slightly, ceramics made marginally tougher, composites tuned for specific stresses. Each improvement matters at the surface, where conditions remain bounded and predictable. Underground, those incremental gains fade quickly. Depth does not ask for better performance. It demands transformation. Heat and pressure rise together, not linearly, but in ways that compound with every step downward. A material that performs twice as well at one depth may fail almost immediately at the next. The relationship between strength and survival breaks apart, replaced by thresholds that arrive suddenly and without negotiation. Laboratories create controlled success. Pressure is increased gradually. Temperature is isolated. Samples are small and exposure brief. Under these conditions, materials can be tested and optimized, their limits mapped with precision. What emerges is impressive, but narrow. These results reflect environments that can be paused, adjusted, and repeated. The interior of the planet offers no such courtesy. Conditions cannot be isolated. Heat arrives from all directions. Pressure never relaxes. Time stretches exposure beyond design assumptions. A material that survives minutes in a test chamber may be expected to endure months or years underground, continuously degrading with no chance for recovery. Scaling introduces further strain. A sample a few centimeters wide behaves differently than a structure meters long. Internal stresses grow. Weak points multiply. Manufacturing imperfections matter more. The margins that protected success in the laboratory vanish once size and duration increase together. What worked in theory becomes unstable in practice. Even the most advanced materials remain subject to the same physical laws as stone and steel. At extreme pressure, atomic structures compress. At extreme heat, bonds loosen. No composition escapes these influences entirely. Improvements delay failure rather than eliminating it, extending tolerance slightly without changing the underlying trend. Depth magnifies small weaknesses. A slight mismatch in expansion rates becomes a fracture over time. A minor chemical instability accelerates under constant heat. Interfaces between materials fail before the materials themselves. Each layer added for protection introduces new boundaries that can degrade. This is why innovation feels stalled underground, despite rapid advancement elsewhere. The challenge is not imagination or effort, it is proportionality. Materials science progresses incrementally. Earth's interior escalates relentlessly. The gap between them widens faster than it can be closed. Physics imposes a ceiling that cannot be negotiated. Energy must dissipate somewhere. Pressure must be supported. Entropy continues its work. Materials can resist these forces temporarily, but they cannot rewrite how matter behaves under such extremes. At a certain point, improvement becomes irrelevant. The outcome remains unchanged because the environment does not compromise. It does not reward adaptation gradually, it overwhelms it. The planet's interior sets conditions that exceed what engineered matter can sustain over meaningful time and scale. New materials extend the conversation, but they do not alter its conclusion. The limits encountered underground are not technological in origin. They are fundamental, shaped by forces that operate patiently and completely, defining where human reach must end regardless of invention. Energy is the quiet constraint beneath every attempt to go deeper, not the dramatic barrier of broken tools or failed machines, but a steady imbalance that grows with each meter. The deeper the descent, the more energy is demanded simply to exist in place, let alone to make progress. Drilling requires power at every stage. Cutting through rock consumes energy. Reinforcing walls consumes more. Moving debris upward adds further cost. At shallow depths, these demands remain manageable, supported by surface infrastructure and predictable losses. With depth, the balance shifts. Energy is spent faster than it can be effectively delivered. Heat changes everything. As temperature rises, removing heat becomes a constant requirement rather than a secondary concern. Cooling systems must operate continuously just to keep equipment functional. Pumps circulate fluids. Fans and exchangers strain against an environment that radiates warmth inward from all sides. The deeper the operation, the more energy is devoted not to descent, but to survival. This creates a paradox. The act of drilling generates heat through friction and compression. The surrounding rock adds its own. Cooling that combined heat load demands even more power, which in turn generates additional heat. A loop forms where energy is consumed simply to offset the consequences of using energy in the first place. Efficiency collapses as depth increases. Early gains feel meaningful. Meters accumulate. Systems perform within expected margins. Then returns diminish. Each unit of energy produces less progress than the one before. More power yields smaller advances. Eventually, additional energy produces no descent at all, only maintenance. The problem is not total energy availability, but delivery and dissipation. Power must travel downward through hostile conditions, losing effectiveness along the way. Cables degrade, fluids overheat, mechanical transfer becomes unreliable. The deeper the system extends, the more of its input is lost before reaching the point of action. At a certain depth, the equation breaks. All available energy is consumed by holding position. Nothing remains to push farther. Drilling heads turn without cutting. Systems stabilize without advancing. Progress slows, then stalls, not because rock cannot be broken, but because the energy required to do so cannot be balanced against the energy lost maintaining operation. This limit arrives regardless of intent or funding. Adding more power at the surface does not solve the problem. It increases heat, it increases stress, it accelerates degradation. The system absorbs the extra input without translating it into depth. Energy, unlike tools, cannot be strengthened arbitrarily. It must obey conservation, loss, and transformation. Underground, those losses accumulate relentlessly. The environment takes its share continuously, leaving less with every step downward. In the end, descent becomes energetically neutral. Effort equals resistance. Motion turns into equilibrium. The drill exists, powered and active, yet unmoving. Progress does not fail dramatically. It fades into balance. This is the energy problem no one can solve, not because the solution is unknown, but because the conditions forbid it. Depth does not run out of rock. It runs out of usable energy, leaving the planet intact and the path inward quietly closed. At first glance, the ocean appears to offer a shortcut. The crust beneath the seafloor is thinner than on land, formed from younger rock that seems more willing to yield. Water already fills the space above, carrying pressure naturally, suggesting that access might be easier from below the waves. For a time, this idea held promise. Beneath the ocean, drilling does begin closer to the mantle. The distance to deep boundaries is reduced. Early progress can feel encouraging as tools pass through layers that would be far thicker on continents. The seafloor does not rise into mountains. Its smoothness gives the illusion of efficiency, of having found a simpler route inward. That illusion fades quickly. Temperature beneath oceanic crust rises at nearly the same rate as it does on land. Heat from below does not care how thin the crust is above it. Within a short descent, equipment encounters the same thermal stress that halts progress elsewhere. Cooling demands escalate rapidly, consuming energy without slowing the inevitable rise in temperature. Water, once thought to be an advantage, becomes a complicating force. It infiltrates fractures and interfaces, carrying heat, dissolving minerals, and altering rock behavior. Under extreme pressure and temperature, water does not remain passive. It reacts, weakening structures and accelerating chemical change. What seems stable at shallow depths becomes unpredictable farther down. Drilling platforms themselves introduce limits. Floating structures must remain stable against waves, currents, and storms while supporting massive equipment with precise tolerances. Any motion at the surface translates downward, magnified through long shafts. Maintaining alignment becomes increasingly difficult as depth increases and conditions below push back unevenly. Seawater also complicates containment. Fluids used for cooling and lubrication must be managed carefully to avoid contamination and pressure imbalance. Leaks that would be manageable on land become dangerous pathways underwater. Systems grow more complex, not simpler, adding layers of vulnerability to an already hostile environment. As depth increases, the initial advantage of thinner crust disappears entirely. Heat, pressure, and material behavior converge just as they do beneath continents. Rock begins to deform. Equipment struggles to function. Energy costs climb steeply. The ocean offers no refuge from the fundamental physics that govern the planet's interior. Even retrieval becomes harder. The ascent of material through water introduces additional stress. Pressure changes interact with surrounding fluid, increasing the risk of collapse or flooding. Every operation must account for two extremes at once: the crushing depth below and the volatile surface above. In the end, drilling from the ocean trades one set of challenges for another without changing the outcome. The planet's interior does not become more accessible simply because the crust is thinner. The same forces that halt progress on land assert themselves here as well, quickly and decisively. What seemed like a clever detour proves to be a shorter path to the same boundary. The Earth remains consistent in its refusal. Whether approached from continents or ocean basins, depth imposes its limits patiently, erasing advantages as soon as they appear, and leaving the inner world just as unreachable as before. Confidence underground arrives unevenly. Some features of the planet's interior stand on a foundation built from repeated observation, consistency, and convergence. Others remain softer, shaped by interpretation rather than confirmation. The deeper understanding moves, the more this imbalance becomes part of the story itself. The large-scale structure of the Earth is supported with remarkable strength. Boundaries between major layers emerge clearly through seismic behavior, gravity measurements, and global patterns that repeat regardless of location or event. The division between crust, mantle, outer core, and inner core is not speculative. It appears again and again through independent lines of evidence, each reinforcing the same underlying framework. Depth, at this scale, is organized rather than ambiguous. Within that structure, motion follows rules that remain consistent. Seismic waves behave predictably when they encounter changes in rigidity or density. Magnetic behavior aligns with the presence of conductive fluid deep below. Planetary rotation influences internal flow in ways that agree with observation at the surface. These relationships hold steady, allowing scientists to speak confidently about how the planet functions as a system. Uncertainty begins when attention shifts from structure to substance. Composition is far harder to constrain. While general assumptions about iron, nickel, and silicate materials are well supported, precise mixtures vary between models. Small changes in temperature, pressure, or elemental distribution can produce the same observable effects. Different internal arrangements can explain the same seismic travel times or magnetic patterns equally well. Because of this, multiple models coexist without contradiction. Each fits the data available. Each satisfies physical constraints. None can be directly verified. Rather than narrowing to a single answer, understanding branches, outlining a family of possibilities shaped by the same evidence, the Earth allows this ambiguity by remaining inaccessible where it matters most. As depth increases, certainty fades gradually rather than abruptly. Confidence does not collapse, it softens. Conclusions become ranges instead of points. Statements shift from exactness to probability. What is known remains valuable, but what is unknown grows larger in proportion. This fading does not signal failure, it reflects the limits of interaction. Knowledge built from indirect observation will always carry interpretation within it. The planet's interior offers responses, not revelations. It shapes signals without exposing their full cause. Understanding advances through agreement among models rather than final resolution. Even so, some truths remain firm. The planet is layered, its interior moves, heat escapes slowly, magnetic protection is generated far below the surface. These statements endure, regardless of composition debates. They form the stable core of what is known. What remains uncertain invites restraint rather than doubt. Competing models refine thinking rather than undermine it. Each version of the interior deepens appreciation for the complexity hidden beneath familiar ground. Certainty diminishes with depth, but meaning does not. The Earth does not conceal everything. It reveals enough to understand its behavior without surrendering its details. What is known with confidence guides exploration of what remains unclear. Between those two, understanding continues, shaped by patience, evidence, and acceptance that some aspects of the planet will always be understood best as possibility rather than fact. Every day unfolds atop processes that remain unseen. The ground feels familiar, stable, and thoroughly known, yet beneath that familiarity lies a vast portion of the planet that cannot be entered or observed directly. Life proceeds as though the whole world were available, while depending quietly on forces that operate far below any path we can follow. These unseen forces shape conditions without asking for attention. Heat rising from depth drives motion that renews the surface over long spans. Magnetic shielding bends harmful energy away. Subtle adjustments inside the planet help preserve atmosphere and water. None of these processes are visible in daily experience, yet they sustain the balance that allows ordinary moments to repeat. The Earth contains regions that will never feel a footprint or a tool, not because of distance alone, but because the conditions there rewrite matter itself. Pressure, temperature, and time combine into environments that do not permit entry. These places remain intact, continuous, and active, existing as parts of our home that must be accepted without contact. This separation does not feel intuitive. Familiarity encourages the sense that what lies beneath is simply more ground, waiting to be reached. Maps give the illusion of completeness. Diagrams fill in layers with color and labels. Over time, representation can be mistaken for access. Understanding begins to feel like possession. Yet, mastery fades as depth increases. What can be named cannot always be touched. What can be modeled cannot always be tested. Confidence built on surface experience weakens when extended inward. The planet does not yield equally in all directions. It allows movement across its skin, but guards its interior through conditions rather than barriers. Living here means accepting that home is only partially accessible. The Earth offers stability without surrendering itself entirely. It supports life while remaining distant from it in crucial ways. The deepest regions do not adapt to human presence, nor do they need to. Their role is not to be entered, but to endure. This hidden interior shapes perception subtly. Because effects arrive without revealing causes, the unknown becomes easy to forget. The magnetic field is felt only when it falters. Tectonic motion is noticed only when it breaks stillness. Between these moments, the unseen fades into assumption, treated as permanent and given. Such assumption carries comfort. It allows life to focus outward, upward, forward. It masks the reality that much of the planet remains beyond reach, active without invitation. Familiar landscapes distract from the scale of what lies beneath them, turning mystery into background. Acknowledging this incompleteness reshapes perspective. The Earth becomes less a possession and more a partnership. Stability appears not as something controlled, but as something maintained by processes independent of awareness. Home is no longer defined by access alone, but by dependence. We live on a planet that cannot be fully entered, yet fully sustains us. Its most vital regions remain unseen, untouched, and essential. Mastery, when assumed, proves illusory. What truly exists beneath our feet is not absence of knowledge, but the presence of limits. Accepting those limits does not diminish the planet. It clarifies our place upon it as inhabitants of a world that continues far beyond where we can ever stand. The sense of safety begins with contact. Feet on solid ground create an impression of permanence so familiar that it fades into the background of thought. Ground feels dependable, unmoving, a foundation that holds without effort. This sensation forms early and persists quietly, shaping how depth is imagined long before science enters the picture. Because the surface feels stable, what lies beneath it is often assumed to be more of the same. Layers of rock are imagined as stacked and still, compressed versions of what is already known. Depth becomes associated with security rather than change, a deeper anchor rather than a different state. The planet appears calm simply because its motion is slow where humans stand. This assumption is powerful. Buildings rise on it, roads stretch across it, entire cities are planned as if the surface represented the character of the whole. The deeper Earth becomes a conceptual extension of everyday experience, familiar by association rather than by evidence. Science gently dismantles this comfort. Measurements reveal motion where stillness was assumed. Heat flows upward, rock deforms, boundaries shift over time. What feels rigid at one scale behaves fluidly at another. The ground beneath human life is not static, but temporarily arranged. This revelation does not arrive through catastrophe, but through accumulation of detail. Seismic records show waves bending and vanishing. Magnetic measurements reflect distant movement. Chemical traces suggest recycling and transformation. Each piece contradicts the idea of depth as a stable stack, replacing it with a portrait of slow, persistent change. The illusion persists because the timescales differ so dramatically. Human senses are tuned to seconds and years, not millions. Motion that takes generations to notice feels equivalent to stillness. Change that unfolds over geological time feels identical to permanence. The earth moves patiently, well outside the rhythm of daily life. This disconnect shapes intuition. Depth feels safe by default because it does not respond quickly. The lack of immediate feedback is mistaken for solidity. In reality, the planet beneath the surface is more active than the surface itself, driven by gradients of heat and pressure that never settle. When science reframes depth, it does not replace comfort with danger. It replaces assumption with proportion. Stability is revealed as local rather than universal. The ground holds firm because forces below it are balanced, not because they are absent. Stillness exists because motion is distributed, not because it has ceased. Understanding this alters perception subtly. The surface becomes a moment rather than a guarantee. Familiarity becomes a thin layer rather than a defining trait. The earth is no longer a quiet object with hidden depth, but a dynamic system whose movement is simply too slow to feel. The psychological illusion does not disappear once exposed. It remains useful, allowing daily life to proceed without constant awareness of underlying complexity. Yet science adds depth to that familiarity, revealing that calm rests atop motion, and stability emerges from balance rather than immobility. Beneath stillness, the planet continues its work. The ground supports not because it is inert, but because it is engaged in processes far larger and slower than perception allows. Recognizing this does not remove the comfort of standing on Earth. It deepens it, replacing illusion with understanding while leaving the surface just as solid beneath our feet. Progress often feels inevitable. Each generation inherits better tools, stronger materials, finer measurements, and faster computation. Limits that once seemed fixed recede, replaced by new frontiers. From this pattern, it is tempting to assume that every boundary is temporary, waiting patiently for the right invention. Yet, not all limits belong to technology. Some belong to the structure of reality itself. Physics does not advance. It remains constant, governing energy, matter, and motion with the same rules now as it did long before tools existed. These rules do not negotiate with ambition. They apply equally to ideas and machines. The Earth's interior sits within this unchanging framework. Heat rises because energy disperses. Pressure increases because mass accumulates. Materials behave differently because atomic structures respond predictably to force. None of these patterns depend on human capability. They emerge from conditions that exist independently of observation. Technology can approach these conditions only incrementally. Better alloys tolerate slightly more heat. Improved designs endure marginally higher pressure. Sensors become more precise. Each advance pushes the boundary outward by small amounts, but the boundary itself remains defined by the same gradients that shape the planet from the beginning. At a certain point, improvement encounters asymmetry. The demands imposed by depth grow faster than engineering capacity. Heat increases continuously. Pressure compounds relentlessly. Energy loss accelerates. No amount of refinement transforms exponential escalation into a manageable curve. Physics enforces proportionality where technology seeks control. This is not a temporary mismatch, it is structural. Even hypothetical breakthroughs must still obey conservation laws, thermodynamics, and material limits. A stronger machine still absorbs heat. A smarter system still dissipates energy. Perfect efficiency remains unattainable. These are not shortcomings of design, but features of reality. Some boundaries are therefore not obstacles, but endpoints. They mark regions where interaction becomes impossible without violating fundamental constraints. The Earth's center appears to occupy such a region. It is not sealed by rock alone, but by conditions that erase the usefulness of tools before they can arrive. This does not render knowledge impossible. Understanding continues through indirect means. Models refine, measurements sharpen, patterns become clearer, but access remains abstract rather than physical. Insight replaces presence, interpretation replaces contact. Over time, this distinction may become more accepted. Exploration need not imply entry. Knowledge need not require touch. The deepest truths about the planet may always come from listening rather than reaching. The center can be understood without being visited. Technology will continue advancing, and boundaries near the surface may shift, but the deepest limit shows little sign of movement. It remains anchored to unchanging laws, not to temporary gaps in capability. Earth may therefore always keep its center hidden, not as a challenge to overcome, but as a reminder that not all mysteries are meant to be entered. Some are meant to be respected, studied from a distance, and carried forward as part of the relationship between a planet and the life it supports. The permanence of this limit does not diminish human curiosity. It gives it shape. By defining where progress ends, it clarifies where understanding must take a different form. In that sense, the unmoving boundary beneath us does not close a story. It quietly completes it. Understanding can arise without arrival. Much of what is known about the planet's interior exists entirely beyond reach, formed through inference rather than encounter. This mode of knowledge feels unfamiliar, even counterintuitive, yet it has become the only viable way forward when presence is impossible. Models replace observation long before depth forbids contact. Patterns in vibration, shifts in gravity, and variations in magnetism serve as inputs rather than sights or samples. From these signals, structures are reconstructed patiently, layer by layer. The work resembles listening to a distant language rather than reading a visible text. Meaning emerges through consistency, not immediacy. This approach alters the role of certainty. Without direct access, confidence depends on convergence. Independent signals must agree. Predictions must hold across time and location. When they do, understanding solidifies even in the absence of confirmation by touch. Knowledge becomes relational, built from how phenomena respond rather than what they reveal outright. Such understanding requires restraint. Models must acknowledge what they assume. Boundaries must remain flexible. Competing interpretations can coexist without canceling one another. Rather than collapsing into doubt, this pluralism strengthens insight by revealing which features are essential and which remain contingent. The absence of presence also reshapes imagination. Exploration has long been associated with travel, arrival, and contact. Maps fill as paths are walked. Objects become known by being held. In the deep earth, this narrative fails. No descent completes the journey. No arrival marks success. Exploration becomes an intellectual act rather than a physical one. This shift challenges instinctive definitions of discovery. Progress no longer means going farther, but understanding better. Advancement is measured by refinement rather than reach. The deepest insights arrive not through confrontation with the unknown, but through careful interpretation of its effects. Knowledge without presence demands trust in indirect evidence. It rewards patience over force. It replaces domination with dialogue, allowing the planet to speak in its own constrained language. Listening becomes the primary tool. Absence itself carries information, as much in what fails to appear as in what does. This mode of understanding is not weaker than contact-based knowledge. In many ways, it is more resilient. It accounts for limits openly, rather than attempting to erase them. It recognizes that some environments do not permit intrusion without distortion. By accepting distance, interpretation remains honest. The Earth's interior exemplifies this form of knowledge. Its most important processes can be described, predicted, and integrated into broader understanding without ever being seen. The lack of presence does not prevent comprehension. It defines the terms under which comprehension must occur. Over time, this reframing expands beyond geology. Other domains adopt similar approaches, learning to read systems through interaction rather than access. Understanding becomes less about proximity and more about coherence. In this light, exploration is not diminished by distance, it is transformed. Knowledge does not require entry to be real. Presence is only one path to understanding, not its measure. The planet beneath our feet remains untouched, yet deeply known, proving that insight can thrive even where no one can go. The descent does not conclude with impact or resistance. It ends quietly, without a final wall or dramatic threshold. Beneath every step, depth continues, indifferent to whether it can be reached. The planet does not announce where access ends. It simply carries on, unchanged by absence. Earth holds its center beyond reach, not through secrecy, but through scale and condition. Heat, pressure, and time combine into regions that remain whole without regard for inquiry. These places exist as they always have, shaping the surface without inviting entry. Their influence arrives gently, stretched across ages rather than moments. Exploration slows, then stops, not because curiosity fades, but because interaction becomes impossible. Tools fall silent, pathways close, motion yields to balance. At that point, the journey shifts inward, away from movement and toward meaning. Understanding continues where descent cannot. This quiet ending reframes what it means to know a place. The earth reveals itself not through access, but through consequence. Mountains rise, magnetic fields hold, continents drift, atmosphere endures. Each surface event carries a signature from below, a trace of unseen motion translating upward into familiar experience. Daily life unfolds within this hidden context. Streets rest on flowing mantle. Compasses respond to distant currents of liquid metal. Seasons pass beneath a shield generated far below sight. These forces operate without attention, steady and patient, shaping conditions while remaining unnoticed. The absence of contact does not imply absence of connection. The deepest regions remain integrated with every step taken above them. They do not retreat from relevance simply because they cannot be visited. Instead, they assert relevance through stability, through continuity, through the quiet maintenance of balance that makes the surface livable. The end of descent is therefore not a failure, but a boundary that defines perspective. It marks the point where presence gives way to interpretation, where effort yields to listening, where the earth asks not to be entered, but to be understood on its own terms. What lies beneath remains active without spectacle. It does not rush. It does not yield. It supports without revealing itself fully. In that sense, the planet offers a lesson in restraint. Not everything essential can be reached. Not everything meaningful can be held. Exploration ends long before understanding does. Knowledge continues through patience, modeling, and respect for limits. The story does not close with an answer, but with a wider awareness of the unseen systems that sustain the visible world. This quiet conclusion invites attention to what usually fades into background: the ground beneath daily routines, the forces beneath stillness, the deep processes that allow life to proceed without interruption. By noticing them, by holding space for what remains hidden, the journey continues in another form. There is always more earth than can be reached. Yet within that distance, there is ample room to keep learning, to keep listening, and to keep exploring the boundaries that shape the world we wake up on each day.